In the first video, I had just run this regression result. So I did a regression between my dependent variable was vote score, the independent variable was party identification. That gave me a model with this adjusted R-square for this degrees of freedom and with this parameter result. So my beta was 74.15. My standard error was very small versus that, 1.86. That gave me a t-score that was humongous in about 39. T-scores really only need to be about 2 to be significant. So this is a very strong relationship. Obviously, there'll be a strong relationship between party and voting. And here are the residual statistics. The residual statistics, the important one is for the residuals, you want a mean of 0. And so the standardized residual value, the standardized, or the regular residual value and the standardized residual values both have a mean of 0. Here you'll see this, one of the assumptions that we're going to have is we're going to have normally distributed error terms. And this one really shows some issues here. We've got some outliers up here. We got a lot of clumping. This is called kurtosis here, where you have really high distributions in the middle. And so essentially, when we just control for one dummy variable, we don't have enough variables in the model to really tease out all the effects. And so one of the assumptions here, we're probably not going to meet this idea that we have normal residual values. Okay, so this can also be seen in this dependent variable versus the regression standardized residual versus the vote score, and we'll see this kind of clumping. If this was a normally distributed error and we had just completely random homoscedastic residual terms, we see a constant pattern throughout this line. We wouldn't see this clumping on this end and this clumping over here. And so those are just indications that our model is not perfect. We knew it wouldn't be. And so we'll just need to kind of do some other tests here. One of the other assumption that we're going to do for the blue conclusion, or the blue assumptions, is we need to make sure that the residuals are no longer correlated with the independent variable. So I'm going to run a quick correlation here. Analyze, correlate. I'm going to do a bivariate correlation. I'm going to go to my last dependent variable. I did party identification with this model, and I'm going to add into it the standardized residual value that I just calculated. So this is standard residual 1, and I'll click OK. When I run this, notice my Pearson correlation between party ID and the standardized residual of this model, right, is 0. So I've met that assumption. The model completely purged the beta parameter from the residual parameter, and so that's good. That met that assumption. Let's go back to this assumption. We had this assumption in normality here. Let's take a quick look at it, and we can actually run a few things to determine whether it's normal or not. So one of the things we can do here is we can go up to Analyze, Descriptive Statistics, and we can click on this Explore tab. The Explore tab, I've already got this one in here, but let me show you what we do. If I go down here and I click that first standardized residual associated with the party ID model, and I just put it in the dependent variable, that's fine. And I don't need any descriptives here, so I'm going to click off the descriptives. I already ran those in the model results above. So actually it makes me take something there, so we're just going to run the residuals again. The plots, I don't want the factor levels, and I don't want the stem and leaf or any of the rest of it, but I want the normality plots with the tests, and there's this test in here that tells me whether I can reject the null. So the null hypothesis for the test is that the residuals will be normally distributed, and I'll run a test to see if I can reject that null. So I'm going to click continue. I'm going to click OK, and it's going to run a bunch of other stuff here. So here's my values. These are the tests of normality that I'm interested in here. So the mean of the standardized residual is still 0. That's good. That's important. And if I go down here to this test, don't use this Smirnoff test, but the Wilkie test or the Wilk test is usually pretty good. This statistic here in the degrees of freedom, it's significant at a very high level, so that suggests that the normal distribution isn't, that I don't get a normal distribution in my residuals. If I go back up here and just look at it, I can tell you that's not normal, right? But if you ever have a concern, you can run that explore and do this. And so we have some issues. It also runs these plots, and you'll see that if we had kind of normal, standardized, normal distribution in the residual terms, we would have kind of equal patterns across here. We wouldn't have these kind of sinide curves or these cosine curves through here. That shows you systemic behavior. And really what that is it's coming off the null category and the Democratic Party, and so shows you there's kind of some misbehavior, but there's kind of randomness in the middle, but there's this kind of tailing of the two party coalitions here, and so you can kind of see that. You also see it, they can do this one, deviation from the norm. You see these sine and cosine kind of plots. That's, again, tells you that you got kind of some weird patterns in your residuals. That's really the first, that's the statistical output that you'll need to conduct for the first model. I'm going to run the second model here. Let me stop this one and see if I need to start another video.